Resistance. What is resistance? You should remember from our last video lecture that resistance is the measure of how easily current can flow through a circuit. It's written as R when we see it in an equation. The unit is an ohm, written as the capital Greek letter omega. It's equal to 1 volt per amp. To continue our water analogy, if I turn a water bottle upside down and I put a small opening, there's only a small amount of water that can flow. On the other hand, if I take the whole cap off, a larger opening allows for larger flow. You can see here that both bottles start with the same volume of water. The one with the large opening has a high current flow because it has low resistance. The one with the small opening has small current flow because it has high resistance. Okay, so that's what resistance is. So now we have to talk about this resistivity thing. It's the measure of how well a given material allows current flow. It's an intrinsic property of the material. Just like density, or viscosity, or the specific heat of a given material, it's just a property. If I change my material, my resistivity will change. But that's the only way it's going to change in a problem. Resistance is equal to rho times length over cross-sectional area. We developed this in class using the Plato lab. Well, mostly. That rho, that's the resistivity of the material. Yeah, I know. We've seen rho before, and it wasn't resistivity. It was the density. So here's the deal. If it's in an electricity and magnetism problem, it's resistivity. That's all we're going to use it for this unit. I promise. Now, technically, the resistivity of that material, it does depend on temperature, but we're not going to deal with it, okay? For any given problem, okay, assume that it stays constant for that material in that problem. So here's the sample problem we walked through in class. The 5 resistors shown are made of material with the same resistivity. Which one has the greatest resistance? Okay, so here's how we solve it. These are my 5 answer choices, and this is the equation we're going to work with. Now, they're all made out of the same material, so the resistivity is the same. So I can ignore that part. Okay, so now to get maximum resistance, I know from the equation that I want to maximize the length. That leaves me with B or D. I also know that to make R bigger, I need to make the area smaller. Okay, so between B and D, they both have cross-sectional area A at the right-hand side, but D has a bigger area on the left. So really, we're kind of looking at the average area, but we don't have to calculate it. Okay? Just looking at that left-hand side and seeing that at any point that D is bigger than B, alright, that means that average area has to be bigger, which means that my resistance is going to be less. Okay? So that leaves me with B, because it has both the longer length and the smaller cross-sectional area. Okay, so this was going to be your homework, but we did it in class. Here's the link. It's also going to be posted on the website under circuits, under materials. Okay, also, I know I said it would be tomorrow I would give you the packet of practice problems. You have it now because I handed it out in class. If you weren't in class, it will be posted online as soon as I post this. Please do not work on them over break. I really mean it. Alright? Enjoy your spring break.